Good morning friends, welcome back. Today we are going to talk about the integers. In this class, today we are going to talk about the properties of addition and properties of subtraction. Both things are very important as far as concerned to the integer topics. So dear students, let's talk about it. In the properties of addition, first property is a closure property. What is the meaning of closure property? Closure property means what? If we add two integers, then answer will be integer. Answer must be integer. So whenever we add two integers, for example, 7 minus 3, it will be 4. And if I reverse it, for example, 3 minus 7. Instead of 7, I write here 3, and instead of 3, I write here 7. So what will happen here? 3 minus 7, we cannot minus 7 from 3, so we have to minus 3 from 7, answer will be 4. But in front of bigger digit, there is a minus symbol, so we write here minus symbol. So at both places, here and here, both answers are integers. Both answers are integer. It's a negative integer, it's a positive integer. But whenever we add or subtract any two numbers, two integers, then we get a answer also integer. That is nothing but the closure property. So let's talk about the commutative property. What is the meaning of commutative property? Commutative property means a plus b plus a. Means what happened here? Let's have one example. If you add any number, any two numbers, 3 plus 5 equals to 5 plus 3, like this. It means that you have changed the place values. Instead of 3, you have write here 5, and instead of 5, you have write here 3. It means that we have changed the place. Okay, we have changed the places. So after changing the place also, the answer will be same. 3 plus 5, 8. 5 plus 3, answer will be 8. So that is nothing but the commutative property. It means that if you reverse the digits by adding, then answer will be the same. So this property is nothing but commutative property. What happened here? A plus b or b plus a. It means that we have reversed the digits, places. We have changed the places. So that is nothing but a commutative property. And in the commutative property, if we add two digits by reversing its place, answer will be the same. So this is nothing but the commutative property. So we talk about the closure property, commutative property. Let's talk about the associative property. What is the meaning of associative property? In the associative property, there are three digits. For example, first digit, second digit, third digit. First digit, second digit, third digit. What happened here? In this property, first we add two digits and then after we add third digit. And in the other hand, we first add last second digits and then after first digit. So let's have one example. If I add 3 plus 5 plus 2, and first I add first two digits and then after I add a second digit, third digit. Okay, 5 plus 3 will be 8 and 8 plus 2 will be 10. Okay, 8 plus 2 means 10. So this 10 and there is also 10. So in the associative property, what happened? In the both cases, this case, first case is equal to the second case. It means that if we add the first two digits and then after third digit, and in the second case we add the last two digits and the third digit, so in the both cases answers are same. Look at here, 10 and 10. In the both cases answers are same. So just because of that, this is said to be a associative property. So let's talk about the next question or next point. existence of additive identity. Means what? Whenever you add 0 with any integer, then your answer will be that particular number. Means that number itself. For example, if I add 0 with 1, what will happen? Answer will be that number itself, 1. Okay? If I add 0 with 2, what will be answer? Number that itself, 2. Okay? So this is nothing but the existence of additive identity. In the additive identity, what we do? We add a 0 with any integer. If we add 0 with any integer, then our answer will be the same. Means that number same. Okay? That number itself. For example, next example. Next third example. This is first example. This is second example. Let's have a third example. If I add 10 with 0, what will happen? Answer will be that number itself, means answer will be 10. So this is nothing but the existence of additive identity. And then after we have to talk about the existence of additive inverse. Existence of additive inverse means what? In this case, for example, if I write here 5 like this, so additive inverse means what? The inverse of 5 will be a minus 5. Means here it is a plus 5. Okay? So that plus 5 will be a minus 5 and the answer will be 0. Say, in any case, if you find the answer of any number inverse, suppose here it is a 5, plus 6, and if you add the inverse of this 6 with it, minus 6, what will be the answer? Plus minus minus, plus minus minus means 6 minus 6 will be 0. Understand? So this is how it is the existence of additive inverse. Additive inverse means what happened? In the additive inverse, we add the inverse number. It means that 5 will be added by the minus 5, answer will be 0. If we have to add additive inverse of 7, then plus 7. What will be the answer? Plus minus minus. So 7 minus 7 will be 0. It means that in the additive inverse, if you add any inverse of that particular number, then your answer will be 0. So this is all about the properties of addition. So let's talk about the properties of subtraction. In the properties of subtraction, what is the meaning of closure property? Here also we are talking about the closure property. What happened here? In the addition of the two integers must be integer. Okay? So even here we have to say that the subtraction of the two integers must be integer. It means that the answer must be integer. After subtracting two integers, our answer must be integer. So look at here, a minus b, it must be integer. B minus a must be integer. For example, 7 minus 3, answer is 4. If you reverse it, 3 minus 7, answer is minus 4. So even 4 as well as minus 4, both are integers. Answer is not changing. So just because of that, it is a closure property. Okay? Understand it? So let's talk about the subtraction of integer is not commutative. Means what? In the addition, commutative property is satisfying the rules. Okay? But as far as comes into the subtraction, this commutativity is not satisfying the rule. For example, a plus b is not equal to b plus a. Why? Because if we have one example of 7 minus 11 is not equal to 11 minus 7. For example, 7 minus 11, what will be the answer? Answer will be 4. Okay? Answer will be 4. Answer will be minus 4. Okay? And so what about this 11 minus 7? Answer will be 4, but plus 4. So just because of the plus and minus, this answer is not matching. So our answer is different. So this is all about the subtraction of integer is not commutative property. Okay. Okay. So now we are going to talk about the subtraction of integer is not associative. So how it is? Okay, a minus b minus c is not equal to a minus b minus c. There is a formula. Okay, in the first case, the first two digits are subtracting, and in the second case, last two digits are subtracting first, and then after we are subtracting this term. Okay, so let's talk about it. I will have an example of this. Why it is not satisfying in the subtraction. Okay, so suppose 5 minus 3 minus 2, 5 minus 2. Okay, what will happen here? 5 minus 3 in the first case. Okay, 5 minus 3 will be 2 and it is minus 2. So here will be 0 answer. And what about this? This 5 is as it is, minus 2 minus 3 minus 2, it will be 1. So answer will be 4. So at both places, in the first case there is a 0 answer and in the second case there is a 4 answer. So in this case, associative property is not satisfying under the subtraction of integer. So this is all about the properties of subtraction, and in the next class we will talk about the next concept. So thank you so much.